Alright, hello. We have a lesson today that a lot of students have trouble with, and that's because, I hate lessons like this, but occasionally you have to have them. This is literally just here's some vocabulary, you've got to memorize it. You've got to be able to match this up. And so we'll do an activity in class where we see how good we are at matching these things. And I'm sure it'll take us a little bit before we get decent at it. So we're looking at basic properties of the number system. And so we want to be able to identify, use, and give examples of properties because they're the basic rules of numbers in algebra. In case you've forgotten, remember a property is a statement known to be true, and up till this point you've probably just assumed that they work. You didn't really think about them. You didn't necessarily give them names. And I expect you to know them by heart by the end of the year. And so we're going to start with properties of the equal sign, which are called equivalence properties. The first one is the reflexive property. And then whatever I put in parentheses here is kind of my attempt to try to help you be able to memorize these. So when I say reflexive property, think reflection. The reflexive property says that for any real number x, x equals x. It's like x looks in the equal sign, it sees its reflection, it sees itself. The symmetric property, I want you to think symmetry. If x equals y, then y equals x. Every time in Algebra 1 you ever finished solving an equation and it said like 2 equals x at the end of the problem, and you felt like turning it around so that it said x equals 2 instead, you were using the symmetric property. The reflexive property, there'll be a version of that in geometry that will be really useful at times. A couple more properties of the equal sign, the transitive property. Of the reflexive, symmetric, and transitive, the transitive property is probably the easiest one for students to remember because the prefix trans, they're used to like transportation. They're used to the idea of movement here. And so think about like move, get out the way, which used to be a sort of a popular song reference there. If x equals y and y equals z, then you can tell y to like move and get out the way, x equals z. And then we've mentioned substitution property already this year. When I say substitution, I want you to think replace. If x equals y, then x can replace y in any true statement without changing the fact that the statement is true. A couple other things. These aren't exactly properties, but they help some of these properties we've got coming up make sense. Subtraction's kind of made up. You learn subtraction in second grade because they don't feel like you're ready for negative numbers yet. So for purposes of this class, I need you to remember that when you say something like x minus y, you really mean x plus the opposite of y. Subtraction is actually an addition of an opposite. Similarly, division is really a multiplication by a reciprocal or a fraction. And you're kind of taught division as a way to sort of cheat on things like multiplying by a half or a third or a fourth. You're taught to do division, but it's actually multiplication by this sort of unit fraction, 1 over number. And please keep in mind you cannot divide by 0. That was in one of our previous lessons. We do this so that we don't have to talk about properties of subtraction or properties of division. By defining subtraction as really being addition and division as really being multiplication, it means that you can just worry about properties of addition and multiplication, and you get sort of subtraction and division for free. Closure, which is the idea of how to combine numbers. X plus y is a unique real number. 2 plus 3 is just always equal to 5. You never add 2 plus 3 when we're talking about real numbers and get something other than 5. 2 times 3 is always 6. And so the idea of closure is that addition and multiplication are unique operations on the real numbers that combine two numbers into one number. I believe we defined operation that way earlier in the year. I hope we did. If we didn't, I messed up and forgot to include that. Associative property is the idea of grouping. And so if you've got these two things all being added together, it doesn't really matter where the parentheses are. It doesn't matter who you group and add first. Same thing with multiplication. Commutative is the idea of about order. X plus y would be the same as y plus x. And same thing with multiplication. Now, these two tend to get confused really easily by students. And so what I try to teach my students in terms of a mnemonic for keeping these two straight is that when you're talking about going back and forth to work, that's often referred to as like the morning commute or commuting. Or if you drive back and forth to a college instead of living on campus, you're a commuter student. And so that commute is kind of like back and forth in the sense of switching the order back and forth. Once you're at work, a fancy word for who you work with is your associates. And so who are we working with? And that idea of switching who's working together, that's the associative property. But that idea of getting back and forth, switching the order, is commutative. And that seems to help some people. Hopefully it'll help you. Identity, think about like who you are staying the same. Each operation has a unique identity, a one-of-a-kind identity. The number that you can add to any number and not change its identity is 0. The number that you can multiply any number by and not change its identity is 1. And then one of the big ideas of algebra is inverses. And inverses cancel. And every number has its own unique inverse. And for addition, it's called opposites, which kind of gets us back to that idea of subtraction. X plus the opposite of x equals 0. For multiplication, it's reciprocals. X times the reciprocal of x is going to always equal 1, with the slight exception that you cannot be equal to 0 because that would have you dividing by 0, or you would have 0 in the denominator. And sort of a big idea that will be important in later algebra courses, or the further you get in math, is that when you combine inverses, they cancel, and they cancel to the identity. So you combine inverses or opposites by adding them together, you'll get 0. If you combine inverses that are reciprocals by multiplying them together, they'll cancel to the identity 1. So 0 is the additive identity, 1 is the multiplicative identity. Opposites are additive inverses. Reciprocals are multiplicative inverses. And I know that's a lot to take in. You may really just need to make flashcards for these properties. Here's one you should definitely already know. The distributive property describes how operations interact. And so you can distribute from both the right and left multiplication over addition. We just did a lesson on distributive property. So this is phrased a little differently because here I'm emphasizing it not so much as a problem-solving tool, but as just the idea of how addition and multiplication interact. Here are all the properties of negatives or opposites, or just the idea of negation in general. And what I would say about these is you really should be super careful how you read these. -1 times x is equal to the opposite of x. A lot of you might have been tempted to say negative x there, but you don't really know what kind of number. -1 times x is the opposite of x. The opposite of the opposite of x, well, the opposite of an opposite is the same. So the opposite of the opposite of x is x. This third one is really just sort of stressing to you that if you need to multiply two numbers and there's a single negative sign involved, it doesn't matter where you put it. If it's easier to move it to being with the second number, you can do that. If it's easier to just multiply the two numbers and then stick the negative or opposite of in front, you can do that. Whereas if it's an opposite times an opposite, an opposite and the opposite cancel, and so you would just have opposite of x times the opposite of y is the same as x times y. And then this last bullet is basically just a special case of the distributive property. The opposite of x plus y, well, you can pretend that's like a -1 and distribute it, and you would end up with opposite of x plus opposite of y. Some properties of 0. Now, you've seen all of these already in the special numbers lesson. They just didn't have names before. Now they've got names. And so there's two ideas related to division involving 0. If you divide by 0, it's undefined. If you take 0 and divide it by a non-zero quantity, that's a typo. That's a huge typo. Ooh, I need to fix that. That's embarrassing. 0 divided by x is not x. 0 divided by x is 0. I'm going to have to fix that real quick. So that's really bad. Sorry. There's some properties of in here that are not included in the presentation. But I didn't want to delete the slides in case I ever needed them with you all later. Let's see if this works. Error message. Let's fix that. Much better. Alright. 0 divided by non-zero number is 0. Multiplication by 0. If you multiply a number by 0, the answer is 0. And we're going to call that the multiplication by 0 property. And then the 0 product property is the idea that if you have a product equal to 0 that's being multiplied here, it's being multiplied, so it's a product equal to 0, then you had to start with the 0. Either x was 0 or y was 0 or both. And we looked at that again in that special numbers lesson. Now, I really only got one example for you right now, because so much of getting these down is going to be like the in-class matching practice that I come up with. So we'll just have to do some of that in practice. And so the example that I did is something that you would have to do in like a geometry or potentially in algebra 2, where you start with something and you change it one step at a time, and you have to explain along the way how you did it. And we're going to use just properties. And so how could you change x plus x to 1 times x plus 1 times x? Where did these 1's come from? Well, you might remember that you're allowed to multiply something by 1 and it doesn't change its value, or you might think of it as, well, these are understood 1's. Well, the actual property that lets you do all that is the identity for multiplication, or multiplicative identity. Some of you might have already, by the way, gotten to this on Alex. And so if you were having trouble with this on Alex, after this lesson, I'd go try it again. Okay, well, how do you switch 1 times x plus 1 times x into 1 plus 1 times x? You might notice these x's kind of were in common, and then now there's just a single copy outside the parentheses. Well, outside the parentheses, you've got times x. That might make you realize that this is the distributive property. Yeah, it's kind of the reverse process of maybe what you're used to for distributing, but it's still the distributive property. Last but not least, we've got 1 plus 1 being 2. And you might be like, whoa, Mr. Grimner, seriously? I got to explain to you why 1 plus 1 equals 2? And I'm like, yeah, I mean, you shouldn't just sort of assume that. And before you get overly flustered and frustrated about having to explain to somebody why 1 plus 1 is 2, I mean, somebody might say 1 plus 1 is always 2. And I would say, yeah, that's fine. Explain to me why you know that's true. What rule or property lets you know that 1 plus 1 is always 2, and somebody might flip back through their notes and realize that's an example of closure. So the first arrow on your notes page is the multiplicative identity. The next arrow is distributive. The next arrow is closure. And that's your 3 steps that every time you've ever said x plus x equals 2x, this is sort of all the work that you're hiding when you skip straight from there to the final answer. And so it's, of course, much nicer and easier to skip all that in between, but you should realize that you're skipping it at this point. Well, that's going to be it for now. Again, I felt like until we get in class, we can play like some sort of matching game or something with these properties. That'll be good for right now. So I'm going to stop there. I'll see you in class. I'll see you next time. Thank you for your attention.